We'll talk today about the most basic elements of statistics. We'll talk about the mean and then the variance. So let's look at this first formula. X bar equals sigma fx over n. X bar is a notation for the mean. Sigma means the sum of x times x over n. So let's see what that's all about. I'll consider this a convenient set of numbers. What I'm going to do is to find the mean, or the average if you like. I'm going to start off by adding them up, and you can see 26, and now we've got, how many numbers are there? That looks like 13 numbers. So if I say equals the 26, which is equal to this cell here, divided by 13, it turns out conveniently that the mean is equal to 2. Well, it's obviously convenient if we can group these together. We've got these categories of 1. I'll hold down the control key and just drag that, or just the control key and drag that down. Gives us 5. We haven't got a 5, so we'll make it up to 4. And how many 1s have we got? If we count those, we'll find that we've got here 1, 2, 3, 4, 5. So we've got 5 1s. And how many 2s have we got? 1, 2, 3, 4, and I will complete the table where I've got 3 3s and a 4. I could just add those up just to check that I've got 13 numbers altogether, which is the same as the count obviously of these numbers here, 13 of those. What I'm going to do now is to multiply these together. So using Excel, I can just go equals that multiplied by that, and then so that I've got C1 by D1, and then I can just drag that down and then multiply those all together, and now I can add these up, and hopefully we've got our 26, which is the same as the sum of these numbers here. So obviously then we just need to divide equals that and get the same answer that we did before. So that divided by the 13, and that gives me, again, the mean is equal to 2. So I'll just drag these down a bit so we can see what's going on, because these are our x values, and over here this is our f, the frequency, and then here we have f times x, which is multiplied together. And then I need to be careful how I type that in. Right, that's it. And so we've got therefore the products, and then so this, you see, looking at the formula that we had here, the mean is sigma fx. So this here is our sigma fx, which is that part of the formula, f times x, and then add it up. Not sigma f multiplied by x finally, f by x first, and then add them up, sigma, and then divide by n, and the n in this case is the sum of the frequency, which is 13. So that's how we get the mean of grouped data. Let's talk about the variance now. The variance is a measure of the deviation from the mean. Let's see what I mean by that. If we've got these numbers, for example, 0, 2, and 4, and then we've got another set of numbers, which is, I'll put them down here, is 1, 2, and 3. Now, let's take the mean of each of those sets of numbers. You can see 4 plus 2 is 6, 6 divided by 3 is 2, so the mean of these numbers is 2, and we can see that the mean of these numbers, 6, is also divided by 2. Now, what's different about these two sets of numbers? Now, obviously these numbers here are more spread out than these numbers here. So we say the variation from the mean is bigger, and these numbers will have a bigger variance than these numbers here. And by the way, the standard deviation is the square root of the variance, which we'll talk about later. But basically we have the two measures in statistics. One is the mean of the numbers, and the other one is the variance, or the standard deviation, and those two figures are the most important measures in statistics. So let's see how we go about getting a measure of the variance from the mean, i.e. the standard deviation. So let's take a look at the formula for the standard of the variance at the moment. Sigma itself is the standard deviation, so squared is the variance. What we're doing is taking the x values and subtracting the mean, and then squaring each of them, and then adding them up, and then dividing by the total number of numbers. So let's do that. So we've got equals. Now I'm going to take this number, subtract from this number here. I'll press the F4 key, as you know in Excel will give you, and then I'm going to give you absolute reference, and then I'm going to square them. I'm going to get 2 minus 2 is 0, 4 minus 2 is 2. Then I'm going to take these numbers and I'm going to square them. So I'll take this number here and then square it, and then okay, and then I can just get the square of those, and finally, I'm going to add them up to give us the total, which is the sigma here in the formula, x minus x bar all squared. We've done, and we're adding them up at the moment, so we can click the tick, and that gives us 8. Now finally, it says we divide by n, which is n is the number of numbers, which is 3 in this case. So I'll take the 8 and divide that by the number of numbers, which is 3, which is something like that. And if I want to, well, I will do, I'll take the square root of those, because the square root of those gives us the standard deviation. So I'll take square root of that, and then that gives us the standard deviation. So this one here is the variance, and this one is the variance, and this one here is the standard deviation. Now if I were to do the same thing for this set of figures, I would predict that have less variance and standard deviation because they're less spread out. Now let's see if that's the case. I'll just put that in the wrong place. I'll just move that down. And so what we're going to do is to subtract each of these numbers from the mean, which is 2, and then square them. And I'll show you the result. And the result in this case is 0.6667 compared to, so the variance indeed is smaller than that. Just to show you what I did once again, I've taken each of these numbers and subtracted the mean and put them here, and then I've squared them, and then I've added them up, and then I've divided by the number of numbers, which is 3. And in this case, I've taken the square root of the variance to give me the standard deviation. So this is the variance, this is the standard deviation. As you can see, this variance and standard deviation are smaller than this variation. That is because these numbers are less spread out than those numbers. So you see, the mean and the variance are the most important, as I said, measures in statistics. The mean is the middle sort of bit, which is the average, and then the variance, or standard deviation, is a measure of how spread out the numbers. So those two numbers together make up the whole of statistics. Yeah. Okay. So we've had the formula. Oh, now what's this? We have another formula here, sigma fx over n. We've got a, let's just ignore the f for the moment, but that is the correct formula, but let's just ignore it. This is for when we have group data, but let's say it's just sigma of x squared over n minus x bar squared, which is the mean. Now what that means is if I do these by that method, we should get the same answer. So let's see if that's true. First of all, it said the formula says sigma x squared here. Well, x squared. So I need to first of all square them. So I'm going to take this and square the and then I'm going to just checking those numbers are correct. And then yes, they're all the squares there. So I'm going to add them up now. Auto sum, and then I'm going to divide that number by 3, so equals that number divide by 3, which is gives us this. And then let me just take a look at the formula. It says sigma x squared over n, which is what I've just done, minus x bar squared. So now x bar is 2, which is here, so I need to subtract that squared. So from that here, I'm going to subtract this 2 squared, long way of saying 4, and then I can see that this is one measure of the variance, and you can see this is also a measure of the variance. So it's those two formulas which are equivalent. You can show that algebraically without too much trouble, but you should learn each of those formulas. Apart from if I were to put an f in here just after the sigma sign, then that would be a more general formula when we have grouped data. So if you're following along with MATLAB doing this, then you might like to put all these numbers into an array, call it what you like, and then perform all these calculations. And you can also use the MATLAB functions to calculate variance. I think it's VAR Well, it's a bit different actually, but we could talk about, because sometimes the formula in the bottom is n minus 1 instead of n. Well, I'll tell you what it is. When we use n, as you see, we've got a set of data, and we find using n, we find the variance. But if someone were to tell you, oh, this data comes from a distribution, it's a sample, and then it's a sample, and you say, well, okay, the mean of this sample is 2. That's fine. So you'd probably say, oh, the mean of the population from whence it came is 2 as well. Yeah, but how reliable, we don't know. But that's the general idea. So the mean of the sample is an estimate of the mean of the population. Now you might say, well, what about the variance? Because we've got the variance of this little sample here. Is that an accurate representation of the mean of the population? And the answer is no. We modify, you can show this algebraically, but we modify the formula with an n minus 1 on the bottom here instead of n. We'll have to modify this one a bit more. Just looking at this formula here, if we replace n by n minus 1, that is a different type of variance. It's a variance which is the estimate of the population from which it is drawn's variance. But as I said, but you'll find that when you use MATLAB formula var, it actually gives you that one with the n minus 1. So just look up the help on MATLAB for that.